Okay, lecture 47. Law of partial pressures, noted by, or discovered by Dalton. States that the total pressure, in our book it's just P, but it could be also labeled as PT for the total pressure, is equal to the sum of the partial pressures of all the gases that are available or are present in the system. And so that's why it goes out dot dot dot, because you can have as many gases as you want in a system. You can have just a few, you can have hundreds, thousands, but whatever the total pressure is, it's equal to the partial pressures of all of the gases summed up. So we have let's look at the first problem. A gas mixture has the following partial pressures. So when we were dealing with argon and we want to show the partial pressure of argon, we put P lowercase argon. If it's methane, we put methane there. So that subscript just tells us what the gas is. So we have 5.7 atmospheres. The partial pressure of neon is 4.11. 4.11. The partial pressure of xenon is 3.15. Partial pressure of helium is 7.35. What is the total pressure? So the total pressure is going to be the partial pressure of argon plus neon plus the partial pressure of xenon plus the partial pressure of helium. So very straightforward. Not much that we can do here. It's an important concept that the pressures, the partial pressures of each compound or each gas are additive. There's really no guarantee of that. Could be that as the gases come in, they interact and either reduce or increase the pressure in some odd way, but it turns out that you just add them up and that's the pressure. So we have, this is 20.3 atmospheres. Let me double check that. And actually it's 3.1 because we're adding them, so we go out to the hundredths place. Good. Now, another way we can approach this, a gas mixture contains HCl, HBr, HF, HI. If the total pressure of the mixture is 10 atmospheres, and the total pressure of is 10 atmospheres, the partial pressures are given except for one of them, what's the one that's missing? So, again, we can write it out. The total pressure is the pressure of HCl gas plus HBr gas plus the partial pressure of HF plus the partial pressure of HI. Now they told us the total pressure is 10 atmospheres. They gave it the partial pressures for HCl, HBr, HF. This is the one that's missing, so we just solve for that. So we have 10 atmospheres. Hopefully I did this right, and the partial pressures won't be over 10 atmospheres. If they are, then we have a problem. HBr. It doesn't look like it. Good. I just change it if need be. And then the partial pressure of the hydrogen iodide is unknown. Just verify. So this is 10 atmospheres. And so 5.5 plus 2.17 plus 1.33. This is exactly 9 atmospheres. And then P is going to be well, because of the significant figures, this is going to be 1.0 atmospheres because of the decimal place, so we lose a significant figure there, but that's okay. And that's our partial pressure. So that's about as tough as it's going to get. Not much more that we can say. But if we want to go into mole fractions, they mention them, and they mention them briefly. It seems like kind of catches you off guard that they have this in here, and then they don't really talk about it much. But if you go further on, and we'll talk about mole fractions again, but they're very, very useful when you get into the higher levels of chemistry. Physical chemistry has several chapters dedicated to mole fractions. That's why it comes up, even though it seems like kind of disappears very quickly. The mole fraction of A is equal to the number of moles of A divided by the total number of moles. And this turns out to be equal to the partial, if we're talking about gases, the partial pressure of A divided by the total pressure. So if we know the partial pressure of a species and we know its total pressure, we can find that fraction, and that's going to be equal to the mole fraction. The fraction of, if we're counting up the molecules, we'll know if the mole fraction is 0.5, that means 50% of all the molecules present are of that species. So since the mole fraction, if we knew the grams or the moles, we could determine that, but we don't know that, but we do know the partial pressures, and this is definitely true. So if we, let's say, I want to do it for parts A and B. We'll just do it for B so that we don't have to sit here all day. But we have the mole fraction of A, and they don't give it here, but the mole fraction is usually denoted by capital XA. So if we have the mole fraction of HCl is going to be the moles of HCl over the total number of moles. We don't know that, but we do know the relationship that the partial pressure of HCl divided by the total pressure. And in this case, it's 5.5 atmospheres, and the total pressure is 10. So this will make it nice and simple. And this is 0.55. And that's 3 significant figures, so we can put that in there. So the mole fraction of HCl is 0.55. The mole fraction of HBr is going to be 2.17. And it's just by chance that I chose 10 atmospheres, making it very simple. But if it was 8.8 atmospheres, then that's what we'd have here is 8.8. So this comes up to be 0.217 atmospheres. The HF is it's going to be 1.33 atmospheres for the hydrogen fluoride divided by the total, which is 10. So this is 0.133. And then no units here. Mole fraction is just a fraction. It's just a number. Sorry about that. You can see that they cancel though. And then the mole fraction of HI is 1 atmosphere over 10 atmospheres, and so this comes out to be 0.10. And due to the loss of the significant figure, we have to leave that as 2, but I'll just make it 3 so that we can have all of these match up in decimal place. Now, because it's a mole fraction, it has to add up. The fractions have to, when you have all of the species together, they have to add up to 1. So we're going to try that out. And if you add up all of these 4, the total is 1. So the mole fraction is going to be between 0 and 1, and percentages will be between 0% and 100%. So when you know all the mole fractions, they have to add up to 1. Okay, and how many milliliters of fluorine are reacted when 150? Oh, this is sometimes I use the same template, and so we don't have to worry about that problem that was from before. So that is all set.